Alrighty, so in this video, I'm going to explain graph W multiplication. And all it is basically if we have two graphs, and the order actually matters for this type of multiplication. Most multiplication, it doesn't matter. But basically, if we have two graphs, or you can have more, which we'll go over later, and then you denote it like this, and you start with the one on the left, and then for each connection, well, you draw out the graph on the left. And then basically for each connection between the edge and two nodes, you see, can you replicate that? So, or for each one in here, right? Each connection between an edge, each edge connection with the two nodes, you see if you can replicate it in this one. So right here, we have a connection between a green and a blue. So the W product for these two graphs in that order is this. And if we were to do it the other way around, so if it was like this, right? Then we would start with this. Start with the one on the left. And then for each of the connections and the one on the right, see if we can replicate. Or nope. Oh, I did this wrong. Connection here, can we replicate it? So we can. You got a green and a green connecting. You have a green. Let's do that. Right. So pretty simple. So then it turns out we actually can square things, which we are going to denote like that. So we just put the graph, and then a squared, and then a little W in the bottom left. So for example, this graph squared becomes this. Because for each of these connections, we see, oh, where can we replicate it? So we have a blue and a blue, so there's a blue-blue connection, so each of these shoots out a blue, because, you know, we're replicating that connection. And then we have two green-blue connections, so each of this green is going to shoot out two blues to replicate those connections, and each of these is going to shoot out two greens. So we get that, and then it turns out we can cube with W multiplication, W graph multiplication, and we get that pretty looking shape. And we can basically just keep doing this and keep getting, new numbers of nodes of each color. And it turns out if we keep doing this for different shapes, the number of green nodes and the number of blue nodes here both happen to correspond to some sequences in the online encyclopedia of integer sequences that are, in theory, kind of unrelated to this graph multiplication, but they still show up there. And you can keep doing that with different shapes that contain a shape with n nodes, two connections between each node, and n minus one blue nodes and one green node. And we can just keep doing this, and we will continue to get shapes, series with each color of node that already appear in the online encyclopedia of integer sequences until we get to an octagon that contains 7 blue nodes and 1 green node. So, if we do it here, all right, well, looks like we have two connections between blue and green. So for the green one, shoots out to create two blues. And then each of these, we replicate those two connections by going like that. Alrighty. Boop. 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 And then looks like we have two blue-blue connections. So, oh no, this is kind of bad. So each of these blues shoots out two blues. And we could just keep doing this, keep getting a sequence of numbers. And, yeah. And then you can do this with more than two colors as well, right? So if we have this shape, then the way we replicate it is by saying, well, let's see, what kind of connections do we have? We have a red-red connection, so each red is going to shoot out a red. And then we have two red-blue connections, so each red is going to shoot out two blues, and each blue is going to shoot out two reds. And then we have two red-green connections, so each green is going to shoot out two reds, and each red is going to shoot out two greens. And so then when we W square this graph, then we get that. So that's pretty cool. And it looks kind of like a fractal, you know? We got these kind of branches and then shooting out two reds. And then if we W cube that graph, then we get that pretty looking thing that looks kind of like a fractal. And so far, the only practical application of these is that they look kind of pretty, which actually, since I'm planning on potentially studying aesthetics, then that actually is very practical for me. But, you know, for any sort of practical application that graph theory is usually used for, like in information networks or whatever, like, nah, you're not going to use this method. But it still produces some pretty looking shapes that might have some applications in aesthetics. And yeah, so basically each of these has, you know, series associated with them, this one too, and you can write them out with what are basically recursive equations, but like multivariable recursive equations, right? So if we wanted to figure out the number of nodes of a color in that, it would be g of 0 equals 1 and b of 0 equals 2, g of n. Well, we're multiplying. G of n would be equal to g of n minus 1 plus 2 g plus 2b of n minus 1, and b of n would be equal to 2g of n minus 1 because of the two connections. And then we already have the number, the g, we already have the blues connections, and we add an additional one plus 2b of n minus 1. And this is kind of sloppy. I'm sorry, I'm not super professional, but I'm just trying to get these concepts out there. Eventually, I will be professional everything, but right now I'm just a high schooler trying to get my concepts out to the world. And so, yeah, this is pretty cool. So we basically have recursive equation, like multivariable recursive equations, and these are actually, from what I can tell, just kind of like the algebraic version of differential equations, but we still haven't done differential equations since I'm still in high school calculus. But from what I can tell, these seem to be kind of similar to differential equations, but just with recursive equations that have more than one variable. So yeah, that's pretty cool. And yeah, this is just W graph multiplication. And so I'm going to do that with the whole octagon shape that doesn't already have a sequence corresponding in the online encyclopedia of integer sequences. And then those are going to be my first things I publish there, and hopefully there'll be more to come. But yeah, this video, I'm going to link to it on my article. And yeah, sorry it's kind of rambling. One day this will be better, but I just kind of get my concepts out there. And hey, look how pretty that is. Look how pretty that is. This is pretty.